PT69, game 2. Okay, so exactly 6 Petri dishes, labeled 1 through 6, are to be stored in an otherwise empty refrigerator. So we're going to have Petri dishes, number 1, 2, 3, 4, 5, and 6. There are 3 available shelves, the bottom, the middle, and the top. The placement of the dishes must be consistent with the following conditions. All right, so I know that this is going to be a grouping game because we have 3 groups that we're trying to place the dishes in. So our groups are the top shelf, the middle shelf, and the bottom shelf. So we have 3 groups, and we're trying to place the 6 dishes in those groups. All right, and we have to listen to the following conditions. All right, so rule number 1, no more than 3 dishes are stored on any shelf. So we can only have 1 to 3 dishes, so no more than 3, however you want to draw that. Or maybe I'll just draw 3 max. All right, rule number 2. Dish 2 is stored at least 1 shelf above dish 6. So 2 has to be at least one shelf above 6. So I draw that with a little dash. I don't do this because it could be that 2 is in the top shelf and 6 is in the middle shelf. It could be that 2 is in the top shelf and 6 is in the middle shelf. So I want to make sure I leave this option open, which is why I just put a dash, just say like, hey, 2's above 6 somehow. All right, rule number 3, dish 6 is stored either immediately above or 1 shelf below dish 5. So what rule number 3 is saying is that 6 and 5 are right next to each other. We're just not sure in what order. This is interesting because we do have an overlap here between 6 and 5. And then lastly, we have rule number 4, which is dish 1 is not stored on the same shelf as dish 4. So 1 and 4 cannot be together. So I do worlds, and that just means that I think about the different scenarios that possibly could be, and I make worlds accordingly. And so I look at the most restraining variable. And so to do that, I have to determine which variables have rules about them. And so 2 and 6 both have rules about them. 5 also does. 1 and 4 does as well, which means that 3s are floater or the least constrained. So for this one, I think what I'm going to do is I'm going to think about where are all the places that 6 could go. Can 6 go on the top shelf? No. So the only places that 6 could go is in the middle shelf or the bottom shelf. So I'm going to create 2 different worlds. So I'm literally going to just copy this one down that I already have. And I'm going to create one world where I have 6 in the middle and one where I have 6 in the bottom. So whenever 6 is in the middle, what else do we know? So in this world number 1, we know that 2 has to go above it. Ooh. But what's tricky about world number 2 is, do we know where 2 has to go? No, because 2 could go in the top or it could go in the middle. But do we know anything else in world number 2? Yeah, we know that 5 has to go in the middle because 5 has to be next to 6. So why didn't we put 5 anywhere in world number 1? Well, because we don't actually know where 5 has to go, because 5 could either be in 2 or 5 could be on the bottom. Do we see that? So if you wanted, which I probably would not do on this game, but you could create another world where you still have 2 and 6 in here. And you do one where 5 is in the top, and another one where 5 is in the middle. And so those are our 2 options. And then lastly, if you wanted to do the same, you could do it for the one underneath as well. So I'm going to make this a little bit smaller. I'm going to make this a little bit smaller. Here's our rules. Top, middle, bottom. We have 5 and 6. And so in one of them, we could put 2 on the top, and in the other one, we could put 2 in the middle. And so for all 4 of us, with just 4 worlds, we actually have 3 of our variables completely taken care of. So we can cross off 2, we can cross off 6, and we can cross off 5. So really all we have to pay attention to now as we do this game is that 1 and 4 cannot be together. Literally. So for sake of saving space, I'm going to erase everything except for 1 and 4 cannot be together, and that 3 is our max. So 1 and 4 cannot be together. Cool. All right, so let's go into the questions. I think I might box these just to make it a little bit easier to see. So there's a world. Here's a world. Here's a world. And here is a world. Okay. Maybe I'm overthinking it, so I apologize if I am, but those are our 4 worlds. Literally the only things that can happen on this game. All right, question 6. Which of the following is an acceptable placement of dishes on the bottom, middle, and top shelves? This is kind of annoying because they labeled them the opposite direction as I did. But what I'm going to do is just look at our rule number 1 and go through them. So rule number 1 is no more than 3 dishes are stored on any shelf. Well, in A, we have 4 on the top shelf, so that can't be. So I'm just going to cross this off. Dish 2 is stored at least 1 shelf above dish 6, so I'm looking for 2 above 6. That happens in B. It does not happen in C because we have 6 above 2, so we can cross C off. Right, rule 3, 6 and 5 have to be right next to each other. That happens in B, that happens in D, but it doesn't happen in E, so I'm going to cross that off. And 1 and 4 are not together. Well, that happens in D, so that cannot be it. So our answer is going to be B. And that works. All right, question number 2. If dish 6 is the only dish stored on the bottom shelf, which of the following could be the list of dishes that are stored together on the middle shelf? All right, so let's look at our worlds. In which scenario do we have 6 being on the bottom? 2 and 4. So that's what we're going to pay attention to. And so we know that 6 is the only one that can go here. So automatically we know that 5 has to go in the middle shelf. And so we're looking at what has to be together. So since I know that 5 has to go on the middle shelf, I'm going to look through my answer choices and see if they all have 5. And if not, I'm going to cross them off. So I can easily cross A off, I can cross B off, and I can cross C off because it doesn't have 5. And so now all I have to pay attention to is, could it be true, because this is a could be true question, could it be true that the only options are 3 and 5 or 4 and 5? So if we were to put 3 here on the middle shelf, what would happen? Well, that would put all of the rest of them on the top shelf. So that would put 1, 2, 4. Well, those are only ones. But why does this not work? Because we cannot have 1 and 4 together. It violates our 4th rule. So it can't be D. And then just to show you why E works, versus on this other one, we have top, middle, bottom, 6 and 5. It's saying that the only other one is going to be 4, is because it would put 1, 2, and 3 on the top, and we have this 1 and 4 split. So that's great, and so E is going to be our answer. All right, let's go on to number 8. If dish 1, 2, and 3 are stored on the same shelf as each other, which of the following could be true? So we know that the maximum number of shelves that we can have is 3. So if 1, 2, and 3 are together, we know that it has to be all on one shelf. So now we need to determine what shelf could this possibly be. So the only time that we ever have 2 by itself in worlds 1, 2, 3, and 4 is in 2 and in 3, and we have it on the top shelf. So we know that these are going to have to be on the top shelf because we can only have 3 total. So we have top, middle, bottom. And so we also know that whenever 2's in the top shelf, oh, I think I messed up one of my rolls. I meant to just draw 5 below here. Sorry about that. It hasn't affected anything so far. But, so we have 1, 2, and 3 in the top. So we know that there has to be this block of 6 and 5. Not sure which one goes where, but they have to be next to each other and they have to be in the middle or the bottom. And then the only other one that we're thinking about is 4, and that can go in either or. So this is a could be true question. So that means that 4 of our answer choices, it's saying which of the following could be true. So only one of these could actually happen. The other 4 could not. So if it could not happen, we want to cross it off. So A says exactly one of the dishes is stored on the top shelf. Well, that could not be true because we know that there has to be 3 on the top shelf. So I'm going to go ahead and cross off A. B, exactly 2 of the dishes are stored on the top shelf. Well, once again, we know there needs to be 3 dishes on the top shelf, so we can cross B off. C, exactly 2 of the dishes are stored on the middle shelf. Could this be true? Yeah, because it could be 6 and 4, or it could be 5 and 4, but there absolutely could be 2 dishes on the middle shelf, so I'm going to go ahead and leave this one. D, exactly 3 of the dishes are stored on the middle shelf. No, there could never be 3 dishes on the middle shelf because 6 and 5 cannot be together. So we're going to go ahead and cross this one off. And then E, exactly 3 of the dishes are stored on the bottom shelf. No, because 6 and 5 cannot be together. And that is why C is our answer. All right, next question. If exactly one of the shelves has no dish stored on it, which of the following must be true? All right, so in what scenarios do we have it that it's possible that there is not going to be a dish on that shelf? So it looks like it's either going to be world 1 or world 4. Do we see that? Cool. So I'm just going to redraw these just for ease of purpose. So top, middle, bottom, top, middle, bottom. So if we have 2, 5, and 6 here, and there's a shelf without any of them, which is going to be our bottom shelf in this scenario, what must be true of the others? Well, we know that 4 and 1 cannot be on the same shelf. So if 4 and 1 cannot be on the same shelf, we know that there's going to be a 4 or a 1 here. And there's also the other one is going to go on the other shelf. Now we need to start paying attention to how many spots there are. So we have 1, 2, 3. So that means our next variable has to go on the middle shelf because we cannot have more than 3 on a line. So the only place that 3 can go in this example is on the middle shelf, because 4 and 1 will just go back and forth. And then in in our other scenario where we have nobody on the top shelf, and we have 5 and 2 on the middle shelf, and we have 6 on the bottom, the same thing is going to happen. We have to have either 4 or 1 on the middle. The other one will go on the bottom, so this also is 4 or 1. And that means that because there can only be 3 on one shelf, this is going to have to be 3. So this is a must be true question, so this is something that has to happen. So must it be true that exactly 3 of the dishes are stored on the bottom shelf? Well, no, because in this scenario here, we don't have 3 dishes on the bottom shelf. We have none. So we're going to cross A off. B, exactly 3 of the dishes are stored on the middle shelf. I'm going to guess this is our answer because in both of these scenarios, as you can see here, we have 3 dishes on the middle shelf. So I really like B. C, dish 1 is stored on the same shelf as dish 5. Well, this does not have to be true because we have 4 and 1 going back and forth in both scenarios. So yeah, does not have to be true. D, dish 2 is stored on the same shelf as dish 3. Actually, that never happens. If you look here, we have 2 on the middle and 3 on the bottom here. And in this scenario, we have 2 on the top and 3 in the middle. So that for sure cannot be our answer. And then lastly, for E, dish 4 is on the same shelf as dish 5. Well, once again, 4 and 1 are going back and forth. So we could put 1 here, and we could put 4 here. And that would not put dish 5 on the same shelf as 4. So this must not be true. And that, again, is why B is our answer. All right, 10. If dish 5 is the only dish stored on the bottom shelf. Okay, so we're saying if dish 5 is the only dish stored on the bottom shelf, and if exactly 2 of the dishes are stored on the middle shelf, then which of the following is a pair of dishes that must be among the dishes stored on the top shelf? So it's saying must be among. So this is a must be true. In what world do we have 5 by itself? The only one that's possible is 3. So let's just redraw this quick. So we have top, middle, bottom. So we know that 5 is the only one here. So whenever this happens, we can actually just fill out the rest of this world because this is what happens since we know that 6 has to be next to 5 and we know 2 has to be above 6. But then in our scenario, it also says that there's exactly, so exactly is an important word, exactly 2 of the dishes stored on the middle shelf. So we have 6 already. So that means that there's 1 more. And if there's 1 more on 2, or on the middle shelf, then how many must there be on the top shelf? 1, 2, and 3. And so if we look at our world, since nothing else can go on the bottom shelf, and 1 and 4 can't go on the same shelf, we're going to know that this has to be 1 or 4, this has to be 1 or 4. And so that's going to leave 3 going on the top shelf again. So we really have multiple times have had to pay attention to this rule that 1 and 4 can't be on the same. So this is saying what must be among the dishes on the top shelf. So does 1 or 4 have to be on the top shelf? No, because these are going back and forth. So it could be, but it must not be. So I'm guessing our answer for this, without even looking at the answer choices, is going to be 2 and 3. Let's see if that's an option. Yep, it's C. And like if you wanted to look at these, like why does it have to be not 1 and 2? Well, because 1 1 and 6. Well, we have 6 on the middle shelf, so that doesn't even work. D, 2 and 4 for the same reasons. 1 and 4 going back and forth, so it must not be true. E, dish 3 and 4. Once again, 3 and 4 going back and forth, so it can't be that. All right, last question. Thank you for being with me so far. If exactly one of the dishes is stored on the middle shelf, which of the following could be the list of dishes stored on the top shelf? All right, so if there's only one on the middle shelf, who could it possibly be? Well, it looks like it either could be 5 or it could be 6. So let's pay attention to just those two. All right. So we could have 5 in the middle, or we could have 6 in the middle. If 5's in the middle, 6 on the bottom, 2 on the top. If 6 is in the middle, 2's on the top and 5's on the bottom. And it's saying which of the following could be the list stored on the top shelf. Okay, so and this is saying if there's only one on the middle shelf, so that means nothing else is here. So if you should already be making a prediction here. What do we know about these two spots? Yes, hopefully we already know that they have to be 4 or 1. Because remember, they cannot go together. So it has to be 4 or 1, 4 or 1, 4 or 1, 4 or 1. And then what about our lucky number 3? It could go either spot in both of these. So this is saying which of the following could be, so this just could be, so it doesn't have to be, it just could be the dishes on the top shelf. Could 1 and 2 be the dishes on the top shelf? Yeah. In both of these it could be. So I'm going to cross that off. Or I'm going to select it, I should say. B, 1 and 5. No, because we never have 5 on the top shelf. 2 and 3. No, because this is a trick answer. But 1 and 4 always has to be, one of them has to be here. So this is leaving out the answer choice 3. Because when it says could be the list of dishes stored, this is asking for a complete list. It's not just asking for a partial list. It's asking for a complete, since it says could be like the list. So think of that as like literally like the full list. So it's not C. D, dish 3 and 4. No, because it would be leaving out 2. We must have 2 to be a complete list. And then E, 3 and 5. Once again, we never have 5 on the top shelf. And that's why our answer is A. All right, I hope you all found this helpful.